Okay, good afternoon, ladies. I'm going to review some of the word problems from the review sheet, and hopefully this will help you on the test tomorrow. Again, if you have more questions, feel free to email me, and I'll do my best to get back to you, but it is conferences tonight. Again, I'll do my best. So this is problem 18 from the review sheet. A depth finder shows that the water in a certain place is 620 feet deep. The difference between D, the actual depth of the water, and the reading is D is the absolute value of D minus 620. You need that a little thicker. There we go. And must be less than or equal to 0.05 D. Find the minimum and maximum values of D to the nearest tenth of a foot. So let's start by setting up our inequality. We have the absolute value of D minus 620 has to be less than or equal to 0.05 D. When we have a less than sign, we do that two-sided inequality. So it's going to be negative 0.05 D less than or equal to absolute value of D minus 620 less than or equal to positive 0.05 D. I'm going to do this like I did before. I subtract D from both sides. I actually don't need the absolute value signs anymore because I split it up. And I get negative 1.05 D, absolute less than negative 620. Is less than or equal to negative 0.95 D. Now this is where people are going to get stuck. My suggestion is break up the inequalities. So you have two inequalities. Your first inequality is going to be negative 1.05 D is less than or equal to negative 620. And your second inequality could be negative 620. Let's thin that out a bit. Negative 620 is less than or equal to negative 0.95 D. Now you solve this like you normally would. Divide both sides here by negative 1.05. Negative 1.05 here. The numbers cross out. I'm left with a D is less than or equal to 590.5. When you just on your calculator, you'll see the rounding better. And on the other side, I'm going to divide both sides by negative 0.95. Divide by negative 9.95. And I get 652.6 is less than or equal to D. Now I know you're going to ask, I divided both sides by negative numbers. Why didn't I flip the sign? It doesn't really matter here because they just want us to list numbers. They don't want the inequalities. So the minimum is obviously the smaller number. It's going to be 590.5 and the maximum is 652.6. Yes, if I was looking at your work and exactly how you solved it, you need to switch the inequalities. But because we're just looking at the end results, we don't care about smaller or larger, because the minimum is obviously going to be the smaller number, and the maximum is obviously going to be the larger number. Okay, question 19. Mr. Brown has $75, whoops, wrong pen. Has $75 to spend on pizzas and soda. Pizzas cost $9 each, and the drinks cost 75 cents each. 5 times as many drinks as pizzas are needed. What is the maximum number of pizzas that Mr. Baum can buy? Okay, well, we have a lot of information. We know the pizza is $9. We know the drinks are 75 cents. Obviously, I'm doing this in school because you just heard the bell. If we're going to let P equal pizza, then 5 times as many drinks as pizza means 5P is going to be my drinks. Because we bought more drinks than pizza, so we're going to write it as 5 times P. Now, go ahead and get an equation. Well, $9 times P is how many pizzas I'm getting, plus 5P times 0.75, because each drink is 75 cents. So if 5P stands for the drinks, I have to do 5P times 0.75. And what is the maximum? Again, the bell. What is the maximum? So that's going to be a less than sign. Can he get for $75? And we're going to go ahead and solve this. This is $9 times P plus 5P times 0.75 is going to be 3.75P is less than $75. Combine like terms, you're going to get 12.75P is less than or equal to $75. Divide both sides by 12 times 75. 12.75, sorry about that. And P ends up being less than 5.88. Now, here's my question. Can I order 5.88 pies of pizza? Not really. They will look at me like I'm crazy. So I can only order whole pies. So what is the maximum number of pies I can order? I can order 5 pies. Because I'm going to round this 5.88 down to the nearest whole number, which is 5. Okay, question 20. The Eye Surgery Institute just purchased a new laser machine for $500,000 to use during eye surgery. The Institute must pay the inventor $550 each time the machine is used. If the Institute charges $2,000 for each laser surgery, what is the minimum number of surgeries they must be performed in order for the Institute to make a profit? We're talking about pricing now and making a profit. Remember, a profit, we want to make more money. So we're actually going to start with how much they get every time they do a surgery. So every time they do a surgery, they get $2,000. So 2,000x. Because every time they get a surgery, they get $2,000. Woohoo, more money for them. Now we subtract our cost from what we get in. So if they have to pay $550 for each surgery, we're going to subtract 550x. Remember, x is the amount of surgeries. Now they want to know the minimum number of surgeries, the smallest amount of surgeries. So that's going to be less than, and all this has to be greater than $500,000, because only when they have more than $500,000 will they make a profit. Remember, your profit is after you pay off all your expenses. So you get money in, you're happy, woohoo, and then you have to pay off all your expenses. You lose money. Profit is the difference between the two. So go ahead, we're going to combine like terms. We get 1450x is greater than 500,000. Divide both sides by 1450. And you get x is greater than 344.82 and a whole bunch of other numbers. We're not going to really worry about them right now. Now, can I perform 344.82 surgeries? I think the person I performed the 0.82 surgery on, not going to be too happy with me. So I have to actually round up because I want to make money. I want more surgeries. More surgeries, more money. So x, well, not even x, we have to perform 345 surgeries. If I performed less than this, if I performed 344 surgeries, I would not make a profit. Then this would not be true. You could try it out. Plug 344 in for x, and you're going to get a number less than 500,000. So it would make this inequality not true. Okay, number 21. Donut shop. Yum. Who wants a donut? A donut shop charges 70 cents for each donut and 30 cents for a carryout box. So Shirley has $5 to spend. At most, how many donuts can she buy if she also wants them in one carryout box? So we know it's 70 cents for each donut. 0.70, don't forget that decimal point. Big difference when it comes to solving this if we don't have the decimal point. Times X for each donut plus 30 cents for the box. Now she has $5. Can she spend more than $5? No. So this has to be less than $5. It could be equal also. Now, how many donuts could she buy if she wants to also buy a carryout box? Well, we have a regular inequality here. Let's just go ahead and solve it. Subtract 0.30 from both sides. You get 0.70x is less than or equal to $4.70. Divide both sides by 0.70. Again, that decimal is very, very important. You're going to get some weird numbers and you're going to be like, I don't know what to do. And then you're going to cry. And, well, we just don't want that. So X has to be less than 6.7 donuts. Now, I don't know how often you go buy donuts, but you can't buy 0.7 of a donut. They look at you strange. I believe me. I've tried. So we need to find a whole number that's smaller than 6.7. That means we need to buy 6 donuts. So 6 donuts and the box will be less than $5.